Okay, we just got to go over problems. Now tomorrow I told you I was going to give you formulas, but I'm not going to give them all. I'll just give you the ones from last night's homework. Oh, okay, so polar 3 first, 1b. Is that it? Okay, 1b. R equal 1 plus sine squared theta. R equal 1 plus sine squared theta. Okay, tomorrow there's going to be one problem where you just have to plot points, and we'll have explicit instructions. Like this one, didn't it say plot a point every 45 degrees? Okay, so 1, 2, 1, 2, 1, 2, 1, 2. Now if you want to make the concentric circles, you can. You don't have to though. Okay, so we're going to just plot a point every 45 degrees. Just plug in. So if you plug in 0, you get 1. Okay, maybe we should draw the 45 degree angle. Plug in pi over 4. See, if it's going to take us that long, come on. What is sine of pi over 4? 1 over root 2, and then you got to square it. 1/2 plus 1 is 1.5, right? Okay, now plug in pi over 2. 2, right? Because 1 squared plus 1. 3 pi over 4. I'll give you a hint, it's like a pattern usually. 1.5. Because sine of 3 pi over 4 is 1 over root 2. You square it, you get 1/2 plus 1 is 1.5. Oh boy. Pi. 1. 5 pi over 4. 1.5 again. Anytime it's root 2 over 2, right? You square the thing. Doesn't matter if it's positive or negative, you're going to get 1/2. 3 pi over 2. 2. 7 pi over 4. 1.5 again, and then back to 1. So all you got to do is connect the dots. So it's kind of like this. It's kind of like a peanut, yeah? You get a peanut looking thing? Okay, no problem then. And then no more questions on the rest? Okay, polar 4. Oh, we're going to finish early then. Okay, polar 4. 2c. So everybody, how come we did number 1 circle? Oh, those are the ones you're doing. Okay, 2c. Root 3 over 2. Everybody understand the first two theorems? When you multiply and you divide complex numbers? I guess so. Plus 1/2 I to the, what's the power here? To the 100th power. So, what are you guys? Class of 2013 or 14? Do not be surprised if tomorrow you see 2013 or 14 up there. Doesn't matter what the power is. Okay, the first step is you have to change this into r kis theta form. You've got to change it into polar form so you can apply the theorems. And what's the fastest way to change from rectangular to polar? Draw the picture. See, now instead of x and y axes, you have real and imaginary axes. That's the only difference. So if I go radical 3 over 2 to the right and 1/2 up, like this, how far from origin am I? What's the length of that vector? 1. How do you get it so fast? Because it's a 30, 60, 90 triangle, right? If one side is radical 3 times the other side, it's a 30, 60, 90. And the hypotenuse is always going to be double the short leg, right? If you haven't figured this out now, people, it's always going to be a 30, 60, 90 or a 45, 45, 90. Either that or it's going to be right on the x and the y axis. That's why if you draw the radical 3 over 2 bigger than the 1/2, it's pretty easy to see. So what's that angle? That's pi over 6, right? Or 30 degrees. So when you change this into polar form, it's going to be 1 kis pi over 6. Anyway, if you just think about it, if I'm going to ask you to raise anything to a really large power, doesn't that number have to be 1? Because if I make it 2, who knows what 2 to the 100th power is? That's right. So it's going to be, if I'm going to raise it to a really big power, it's going to be 1. Okay, So how do you raise a complex number to a power? You raise r to that power. So what's 1 to the 100th power? 1. And then you multiply the angle times power. So what's 100 times pi over 6? 50 pi over 3. If you reduce it, right? See, and that's your answer right there. All you have to do now is just put it back into a plus bi form. See, you guys, right now, still, you guys don't understand how powerful this theorem is. What if I ask you to do this to the 100th power? You got to use the binomial theorem. We're going to have 101 terms. Most of you don't even remember the binomial theorem. You guys would struggle if it was second power even. Look how fast it is if it's a polar power. This is one of the most powerful theorems you will encounter. Okay, but see, this angle is kind of too big, so we want to reduce it down to an angle we can work with, right? How do you reduce an angle down? What do we do? You can add or subtract any multiple of 2 pi, and you're going to end up at the same place, right? So how do I reduce it down to an angle you can work with? Okay, this is what I do. Change it to a mixed number. What is 50 over 3? Oh my goodness. 3 goes into 50, 16 times and get 2 left over. So isn't this the same thing as 16 and 2/3 pi? If we change it to a mixed number. So what would be a good multiple of 2 pi to subtract from that? 16 pi. Oh gosh. So if I subtract 16 pi from that, you get 2 pi over 3. See, now didn't you guys do this last year? Mr. Rubash gave you really huge angles and you got to reduce it down to an angle you can work with. Just subtract multiples of 2 pi. So I subtracted 16 pi. And is 2 pi over 3 an angle I can work with? Yes. Now, after doing last night's homework, do we really have to write this out now? Cosine 2 pi over 3 plus I sine 2 pi over 3. For those of you who did last night's homework, after a while, it's kind of tedious just keep writing it out, right, all the time. Just go straight to the answer, right? Because this is what KISS stands for. Okay, so what's cosine of 2? Just do it in your head. What's cosine of 2 pi over 3? Negative half times 1. Oh my gosh. What is sine of 2 pi over 3? Radical 3 over 2, so times the 1. And then you put the I on the second one, right? And there you go, that's your answer. Okay, never mind you guys, just write it out like this. There you go. So, if I were to raise this to the 100th power, that's what you would get. So, what's the only difference tomorrow? I changed this to the 2013 power. The only difference is that this number is just going to be bigger. But just reduce it down the same way, right? Change it to a mixed number, and then you can see what multiple of 2 pi you can subtract, right? So it's really not that hard. Just the key to the problem, though, just make sure you change it into polar form correctly. Because if you don't do it correctly, well, it won't be a fatal error, but it's kind of a critical error. Okay, next. And then 3c. So 3c. Where's 3c? Wait, I did 3c. Oh, 3c. What about 3a and b? That's odd. You guys can do a and b, but not c. As usual. Z to the 4th equals negative 8 plus 8 root 3i. Okay, first step is you have to change this to r KISS theta form. You have to change it to polar form. What's the fastest way? Draw the picture. Here's the real and imaginary axis. If I go 8 to the left and 8 root 3 up, how far from Oregon am I? 16. How do you know that's 16? Again, it's a 30, 60, 90 triangle. The hypotenuse could be double or short leg. You know SAT 30, 60, 90, the one in the directions? That's the one right there. So that means this is the 60-degree angle here. So what's this angle there then? Yeah, it's 120 or 2 pi over 3. So That's what you have to do. You have to change that into polar form first. Okay, now once you change this into polar form, did you guys look at the complex roots theorem? Must be, because you guys did A and B. How many answers are there going to be? 4. If somebody asks you to solve it, what did we learn in the second quarter? If you have a polynomial equation of degree 4, how many answers are there going to be? There's going to be 4 answers. You have to find all 4 answers. Okay, but you find the 4 answers by using that complex roots theorem, because see, this is a complex number. Okay, so let's apply the theorem. Now, okay, here, should I even write the theorem on the board for you? Because some of you don't. If z to the nth power equals r kiss theta, then z, in other words, solving this equation, is equal to the nth root of r kiss theta plus 2k pi all over n, where n is equal to 0, 1, 2, dot, 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 n minus 1. This is the complex root theorem. This is how you get your 4 answers. So let's identify the things. What is, in terms of this formula, what is this? Because tomorrow I'm going to give you this formula on the paper, you know. All you got to. It's right there. I told you in the morning when the sun is shining in, you got to turn your head. Because sometimes it doesn't look right. Anyway, what is this number here? That's n. Okay, what is this? That's r. And what is this? That's theta. All you gotta do is plug it in. It's like no thinking involved. It's just plug and chug. Probably the hardest part for you guys would be memorizing this formula, but it's gonna be on the paper tomorrow. Okay, so what are the 4 answers for this problem? Z equals, okay, follow the formula. What root? What number do I put here? The 4th root of 16. See how I make it come out? Because everybody knows the 4th root of 16 is 2, right? Kiss, just follow the formula. Theta, what is theta? 2 pi over 3 plus 2k pi all over n. What is n? 4, where k equals 0, 1. When do I stop? You stop at n minus 1. So in this problem, if n is 4, you stop at 3. Let's see how you have 4 numbers, because that's because we're going to get 4 answers. Okay, how do you think I'm going to get these 4 answers? You just plug in 0, 1, 2, 3 into this formula. That's how you get the 4 answers. Okay, so the first answer is, okay, what is the 4th root of 16? 2, kiss. To get the first answer, all you do is plug in 0 for k. That's all you do. You get pi over 6. Okay, the next answer is, now I'm going to plug in 1 for k. What is 2 pi over 3 plus 2 pi? Which is 6 pi over 3. 8 pi over 3 divided by 4. 2 pi over 3. Okay, to get the next answer, you plug in 2. Okay, you guys just could stand there, okay? And finally, plug in 3 pi. 3. If I plug in 3 here. People, this is just plugging in. This is not anything exotic, you know. What? 5, 5, 6. Okay, trust me. There you go. These are your 4 answers. Does everybody understand, first of all, you gotta have 4 answers? Because every single year I get this problem. So many people just put 1 answer. No. If you have a polynomial equation of degree 4, there better be 4 answers. So tomorrow, this 5th power, there better be 5 answers. And then, you guys know how to change it back right into a plus b by 4. Because again, I'll do one of them for you. What does KISS stand for? Cosine theta plus I sine theta. Okay, which is root 3 over 2 plus sine of pi over 6 is 1/2. Distribute the 2, root 3 plus 1i. There, that's the first answer. And you just change all the others. But then see, for those of you keeping up with your homework, you know it's going to be that, so why not just look at that and go straight to the answer? Just go here, in your head. What's cosine of pi over 6? Root 3 over 2 times 2. Root 3, so you just write that down. What's sine of pi over 6? 1/2 times it by the 2. You get 1 plus 1i. You practice this a couple times, it's not hard. Now, does anybody notice a pattern? Of course not. Okay, what if I were to graph these 4 complex numbers? Remember, what is a complex number again? It's a vector in the complex plane. Okay, I'm going to draw a circle of radius 2. How do you graph this? You draw a vector 2 units long, and it makes an angle of pi over 6. So it's kind of like that. Yeah? A complex number is a vector. What about this one? 2 units long, making an angle of 2 pi over 3. What about that one? What about that one? What do you notice about these 4 vectors? Hey, they're all equally spaced apart. Oh, does that always happen? Height. Okay. So if you know they're always going to be equally spaced apart, once you find that first answer, right, then all you have to do is just add 90 degrees every time, right? Because if you have 4 things equally spaced apart, 4 goes into 360 90 times, right? So once you find the first answer, just keep adding 90 degrees. See? This is like 30 degrees. Add 90 to that. Ooh, 120. Add another 90. 210. Add another 90. 300. So you don't even have to use this formula after a while. You just find the first answer. Okay, are you sure you don't want me to do 3A or B? Okay, but now I'm going to erase the formula. Because see, remember I told you, if you know this, you don't even need the formula. Okay, somebody read it to me. 3b. Z cubed equals negative 8i. Now, if I were me, I would put 0 minus 8i, just to help you out. Okay, first step is to change this into polar form. Draw the picture. If I plot the point 0, negative 8 down here, how far from origin am I? 8, so that's this. And what's this angle? 3 pi over 2. Draw a picture. That's how you change from rectangular to polar. Okay, now, watch this. I hope, did you guys realize that the complex roots theorem is simply the reverse of de Moivre's theorem? Apparently not. No. So the first thing you do, since n is 3, you take the cube root of this number. What's the cube root of 8? 2. See how I always make numbers that you can cube root or fourth root or square root? And then what am I going to do with this? You divide it by 3. Because look, if you look in the formula, what is it? Theta plus 2k pi over n, right? What happens when you plug in 0 in for there? Basically, you're just dividing the angle by 3. And that's because you're doing the reverse of de Moivre's theorem. De Moivre's theorem, don't you multiply? When you use de Moivre's theorem, when you raise it to a power, don't you multiply that times the angle here? Yeah, so we're just doing the opposite. You're dividing. Okay, anyway, divide that by 3. Pi over 2. That's the first answer, but how many answers are there going to be? There's going to be 3 answers. So 2 kiss something, 2 kiss something. All the angles are going to be equally spaced apart. So if the first one is at pi over 2, and they're equally spaced apart, what's 360 divided by 3? 120. So they're all going to be 120 degrees apart. It's kind of like a Rolle's curve, except it's not a Rolle's curve. Okay, so what's this one going to be? 7 pi over 6. And what's that one going to be? 11 pi over 6. You don't need to use the formula anymore because you know they're equally spaced. And then once you get this, okay, I'll give you a hint. Tomorrow's test, read the directions. Because tomorrow's test might say, just leave your answers in R-KISS theta form, and then you just function. You don't have to change it. So read the directions. What form to leave it in. Because if it says, write your answer in A plus BI form, then you got to change it back, right? But since tomorrow we got assembly period, who knows? I'll just tell you that. This problem on tomorrow's test is just going to say write it in R-KISS theta form, so that's it right there. Okay. Now there's more practice, yeah? For those of you who need practice. See, tomorrow you are getting the week test, So you're going to get all of these complex numbers formulas. Tomorrow, I am not going to give you these though. You are not going to get these formulas. Tangent theta equal y over x equals r cosine theta, y equals r sine theta. Yay! You're not getting those, but you will get all the ones from last next homework. Yeah. Oh no, you're only handing in 1, 2, up to 4. Okay, look at polar 5 though, because although this problem is not going to be on the test because I'm giving you the weak version, I want to do it for you. Where is it? There, number 10. Look at number 10. If z is equal to 1 over root 2 plus 1 over root 2I, compute, so if z equals this, compute z plus z squared plus z cubed plus dot 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 all the way up until z to the, what power did it have there? 2002. I made that problem in 2002. So I guess this year is 2013, so I would do that then. No, it's not as hard as you think. Okay, let's just go. No, we're going to do 2013. Okay, so this problem, it looks kind of complicated, but it's really not, you know. First step, change this into polar form, arc is theta. Okay, draw the picture. If I go 1 over root 2 to the right and 1 over root 2 up, how far from the origin am I? You gotta be joking. How far from the origin am I? I'll give you a hint. This is a 45, 45, 90 triangle. In a 45, 45, 90, let's look at the SAT directions. If you know the length of the side, how do you find the hypotenuse? You multiply it by radical 2, 1. And then what's that angle? Since it's a 45, 45, 90 triangle. 45! Pi over 4. So 1 kiss pi over 4. That's how you change it. Or you can use the Pythagorean theorem, but why? It's going to come out to 1 anyway. Okay, so this is z. Z is 1 kiss pi over 4. Okay, now you got to square it. How do you square this? What theorem do I use when you raise a complex number to a power? You use de Moivre's theorem. So how do you square this? You square this number. What is 1 squared? 1. And then you multiply the angle times 2, right? So what is pi over 4 times 2? Pi over 2. Okay, now let's do z cubed. How do you raise this number to the 3rd power? You raise 1 to the 3rd power, which is 1, and then you multiply the angle times 3. 3 pi over 4. And you just keep on doing this until you get to the 2013 term. What's the part that's crazy? No, there's a pattern. Who's going to do 2013 terms? Okay, don't raise your hand. People, let's draw the picture. Then you can get. So here's a circle of radius 1 in the complex plane. How do you graph this complex number? 1 unit long, making an angle of 45 degrees. Boom. How do you graph this one? 1 unit long, making an angle of pi over 2. 1 unit long, making an angle of 3 pi over 4. Do you see what the pattern is? Hey. So what's the next one going to be? The one right there, because you keep on adding. The pattern is you keep on adding pi over 4 every time, 45 degrees, right? So the next one's going to be here, the next one's going to be there, the next one's going to be there, and the next one's going to be there. Now, what would happen if I added these 8 vectors together? Even in chemistry, people, because last year they told me, chemistry, you guys learn vectors, right? The basics of them anyway. What happens when you add these 8 vectors up? Oh, gosh. And you guys in physics should be ashamed if you don't know this. If I add these 8 vectors up, what do you get? With the 0. Because look, this vector cancels this one. Because they're exactly the same length and they're pointing opposite ways, so don't they cancel each other out? Who's in physics here? Okay. Nobody's in physics. 2 people. Is that it? And the rest of you in chemistry? But they said something about dipoles last year. If they point opposite ways, they cancel each other out. But doesn't it make sense? Look, Bert is pulling this way at something. Ernie is pulling that way at the same strength. Don't they cancel each other out? Oh, now I get it. Okay. So doesn't this one cancel down? This one cancels down. This one cancels down. They all cancel out to get 0. So what's the pattern? Every 8 will cancel out to 0. Oh, so if every 8 cancels out to 0, and you have 2013 terms, how do I figure that out? How much is left over? Okay, thank you. You divide. 8 goes on to 2013. 8 goes into 22 times. So that's 16. 40. 8 goes into 41 5 times. So that's 40. 1. 8 goes into 13 1 time. So that's 8. There's 5 remainder. So basically, there's 251 groups of 8, but they all cancel out to 0. But there's 5 left over. And what 5 are there? Either the first 5 or the last 5, right? Why don't we look at the first 5? Here's the first 5. 1, 2, 3, 4, 5. Those are the 5 that are left over. So then what? Don't these 2 cancel out? Because they're pointing opposite ways. So the only ones left are this, this, and this. So the only ones that are left over are 1 kiss, that's pi over 2. This one is 1 kiss, 3 pi over 4. And this one is 1 kiss pi. And then what you do is you change them all back into a plus bi form, and that's your answer. Okay, this problem is not on the test tomorrow because I'm giving you the weak version. Okay? Okay, so we got a few minutes left. Okay, you want me to tell you what's on the test? Oh, no. Okay. You guys don't even say yes. You can't even say yes. Period 3. Something's wrong with you guys. I've never had a class like this before. At least the desperation will sink in and somebody will say yes. Okay, number 1, 2, and 3. I'm pretty sure that's like the 1, 2, and 3 on the quiz. That was on the quiz. You gotta get your trig values right for problem 1, number 1 though. Come on. Anyway, the reason why I take off 2 points, but tomorrow gonna be 3, is because if you just look, if you plot, what was the original problem? 4, comma, I can't even read that. 5 pi over 3? 5 pi over 3?
Yeah.
Look, if you draw the picture, where's 5 pi over 3? Right here. And you go 4 units from the origin. Come on, you're in the 4th quadrant. Shouldn't the x-coordinate be positive and the y-coordinate be negative? Yeah, so that's why if you get like, you mixed up the signs or anything, that's why, come on, double check like that. There, the first 3 problems can be just like that. Also, Mr. Park, number 3, I gotta remember the law of cosines then. Yes! That's how you find the distance between 2 points. You gotta use the law of cosines. Okay, then you're gonna get a bunch of problems where you have to go draw the graph, but I'm gonna tell you how to do it. So it's gonna say draw this graph, change it to a rectangular equation. So I'll tell you how to do it. That's like the most efficient way. Draw this graph. Now, if it doesn't say anything, then it's going to be one of the ones you're supposed to know. You know what I'm talking about? Yes or no? Like this. R equal 3 plus 2 sine theta. Manapua. Why is he saying Manapua? 1 minus 3 cosine theta. See, there's no hint or anything, so that's one of the ones you gotta know. Inner loop. What's an inner loop? Oh God. No, lemniscate. R squared. Oh gosh. Rose curve, 5 petals. See, these are the ones you just gotta know already, right? What about this? R equal -5 sine theta. Circle. Okay, but the other ones have hints. And you, like I said, and then you're going to have another chance on a hyperbola or ellipse tomorrow, because some of you, I don't know. And then it's going to change it to a rectangular equation. So you're going to do, you see that problem right there? You're going to see that one again. It's either a hyperbola or an ellipse. You guys got to learn how to complete the square, because the first chapter in the third quarter is we're going to study conic sections, and I assume you guys know how to complete the square already. Because some of you are having problems in algebra issues. And then you're going to have two problems where you have to find where they intersect, just like, you know. And then the last problems are last night's homework, but I'm going to give you the formulas. So this is a kind of watered down test, but that's okay. We need a big number, yeah. But tomorrow is assembly 2 now. Okay, we're done. Bell rings in 3 minutes, I believe. Today is assembly 2. Does anybody know why it's assembly 2? What? Wait. We have assembly 2. So the orchestra and chorus is practicing during assembly 2. So it better be really good tomorrow.
You can count on the orchestra. I don't know what the choir.
Wait, say that again for the video.
The orchestra will be good.
What about the chorus?
I'm in the choir, so I don't know. We're practicing.
Wait, is that really true?
What?
Assembly 2 today is to rehearse. Well, how come you can't rehearse in your class?
I don't know. Well, we rehearsed with the orchestra several times. I don't know why we have to.
Oh, because you're going to rehearse together as a group then.
Or like they're going to be, I think they're going to be far away from us too in the orchestra tomorrow. So.
Okay, whatever.
But we're singing a song from a
Anyway, and then bonus points. Okay, this week we're not playing tennis. Yep, no tennis this week. So if you want bonus points, I think the only way you can do it is you're going to have to email me, and then you're going to have to meet over Christmas vacation. No, email me, but you better make sure you have at least several other of your friends with you though, because I'm not gonna go somewhere like Mr. Park. Can you meet us at? Well, I don't know where you guys live. Can you meet us at Kahala tennis courts at 10 o'clock? Then I'll send back. No, you come to Kaneohe tennis courts at 10 o'clock, because I live in Kaneohe. So that's the way you can get bonus points. Because when we come back, all we have is 3 days. We're reviewing for the final exam, and then we get the final exam, right? And for those of you who want to get a head start on the review, just download the stuff from the website, yeah? Yeah, right. Doesn't matter, we're just going to do all review, and then hopefully you're ready for the final exam, which is worth 10% of your grade. It doesn't count on your first, you guys, juniors, you guys know that now you're going to get a semester grade. You never had semester grades before, right? So now that you're juniors, you're going to get a semester grade for the year course, and you know what they use that for? They use that for ranking you. Even though ELI doesn't rank, you get ranked. No. So then the college counseling people, they know who's number 1 and who's number 240. So they don't make it public, but internally they use that to rank you. I think. Anyway, this first semester exam doesn't count on your semester grade though. It's just the average of the first and second quarter. It's just 10% of your final grade.